For part A, I guess you didn't have to build the acceleration function the way I did. You can just take the velocity and then just put into a calculator map 8, get directly to that acceleration a sub 1. I just, for some reason, decided I was going to show the steps from velocity to acceleration, but I didn't have to. Part B, we got that speed formula. And so this one, we have to use our calculator in different ways here. We have to plug in our speed equation, understand that, oh, we're not trying to find the speed. We already know what the speed is. We're trying to figure out what the time is. So we have to kind of play around with that equation, put it over to one side, get that 0 to show up, and actually graph that messy function and look for the x-intercept to find the time when the speed is exactly 1.5.
On the AP exam, like for the D on page 2, is it okay if we just leave it as like x prime with t squared plus y prime with t squared, or do you want us to plug in that x prime and y prime function?
You don't have to go, you got to show this step, but this is what I'm plugging into the calculator.
Okay.
Right, so I think College Board will be okay if you didn't write out the entire function that you're putting in the calculator, but you know, because we have enough, there's enough reference points where the grader knows that you're talking about this function.
Okay. That's just as long as it's stated somewhere in the problem.
Right, it wants to stay somewhere in the problem where the grader can reasonably see, okay, all right, this is what you meant to do, and but yeah, so sometimes I show more than what is needed because I like to explain through my steps. So yeah, just keep that in mind as well. Yeah.
So for the parametric equations, distance traveled is the integral of the speed.
Right.
And then for normal, like just linear functions, not linear functions, it's going to be the arc length is then 1 plus the derivative squared.
Yeah, square root of 1 plus f5.
And so if it asks you for like arc length is pretty much distance traveled for a parametric, right? Like you wouldn't be asked for arc length of a parametric because that's just distance traveled.
Yeah, so distance traveled in parametric would be integral square root of x prime squared plus 1 prime squared.
And that would be the same as if it asks you for arc length for parametric. I mean, it's the same thing.
Yes, that's right. That's right. Yeah. Arc length for parametric is same as total distance traveled for parametric. All right, part C, find the slope of the tangent line. So you have to understand that tangent requires order pair and slope. And we got to do a little more work if you want to do tangent line that is not where you're not given a function, you're given a parametric form. So we know dy dx is the vertical and horizontal components put together. So we can find dy dt at 1, find dx dt at 1, get those to reduce or to be divided. We get 0.63. So that's the slope. And then find the x coordinate. So we have our horizontal component. We know we're looking for x of 1. We know x of 0 is 1. So I like to go to that final equals initial plus displacement just for my x horizontal components to get to my x of 1. And yeah, like you were mentioning for part D, they could have said find the arc length of the parametric equation, same as total distance. That's nice. Just really part D is just, if you know the formula, you can just plug it in. You don't even have to show any work.
You plug in 1 plus dy over dx squared, squared would give you the same thing.
It should. Right.
Well, actually, wouldn't you,
Mm,
Mr. Yang,
yeah.
on that right there on your board? When you do it in a parametric form, don't you have to integrate with respect to dt? So would you have to change the balance to x if you do it the other way?
Oh, you're right. That's a different variable, right?
Yeah.
Yeah.
So if you do the x of t equals 0 and the x minus d, then maybe it would work that way.
Position 1, 0. Yeah, so we have to find out the x value. Wait, but this is still in terms of t though. Hmm. Yeah, let me think about that. I'm not because I am. Okay, so you're saying plug in 0 and pi into the x of t. Oh, but it says x of t is not explicitly given.
Well, it might not work. Yeah. It's not
Right. But yeah, but you're right. It should, right? We should be able to get that connection though, that these two formulas are just variations of each other.
I think you showed us one time.
Oh, changing the bounds into the appropriate x so that we can use that. Okay, if we can go ahead and let's see if we can go to page 7. I want to do a BC FRQ here. Part A is not a BC problem, but part B and C, we're going to get that that BC topic kind of got that improper integral going on for part B, and then for part C. Yeah, there's integration by parts that we have to use there. And but part A is just area, top minus bottom. Try that. Oh, this is non-calculator, so we want to be able to have to go through all of our steps by hand. Okay, page 7. Right, so the integral from 0 to 3 of f of x, that's given to us. Don't have to do any work for that. But the for the g of x portion, a little bit of use substitution. But you can leave your answer in any of these variations that I have. I just cleaned it all the way down to 12 natural log of 2, but you don't have to go this far. If you have 12 natural log of 6 minus 12 natural log of 3 with a 10 in front, that's fine as well. So don't think that you have to clean up your answer to my variation. Okay, part B, you have the improper integral, but with improper integral, we're still going to go through our full um, process. It's just at the end, we just are going to decide whether pushing that B out to infinity is going to give us a finite solution or diverging solution. So part B ends up being another U substitution problem. After U substitution, keep in mind that this is U squared in the denominator. This is not going to be natural log rule, right? This is a power rule. Got to bring that variable up to the top first before you apply your integral rule. And then after you plug in B and 0, notice the B is in the denominator. So that's going to safely allow my first term to go to 0. 0 plus 144 over 3 is going to be a real number. This is going to be a finite solution. Recognizing the need for integration by parts for part C. And then let's see if we can get started on page 8 with our series problem. It's been a few minutes on page 8. See if we can get through part A. For page 8, number 6, you're given your third derivative. So to get from the third to the fourth derivative, you have to go through product chain rule. And then put it into the form for your Taylor polynomial. And then build your fourth degree Taylor polynomial. Or Maclaurin polynomial. Okay, so I'll check the 2023 FRQs on Wednesday tonight. Just focus on studying for your 10 multiple choice test tomorrow over Unit 4B packet. All right, come get your phones. Sure. Great, thank you.
On this one. So I got the bounce like this, right? I saw for beta, and then we got Pyro 6, Pyro 2. I didn't know like in this one obviously there's no Pyro 2, so Pyro 6, but like if it wasn't multiple choice, I would know which one is your balance.
Let's figure that out.
The limit of. That's kind of solid time where it's like n+1.
There's no more.
Yeah.
I think we have to understand that anytime our polar graph has an odd degree, that it will complete its full cycle in pi.
Yeah.
So one petal will be pi over 3.
So how do I not? Yeah.
Uh-huh.
So how do I know?
Yeah, it's fine.
So how do you know it's this?
It's not. It's not like pi over 2 to something else.
Right, so
Smaller than another.
if that's the case, I would build it out, because sometimes I don't know how the graph is coming along.
Yeah.
I would do theta and R, and I was figuring out, okay, where's my graph starting? Can I map out the graph to see?
Yeah.
But wouldn't it? And it, so then if you did that, it wouldn't hit 0 at pi over 2.
You'll do fine.
So at 0, it's only 4, so that means the graph is.
That's more like the peak.
At 3 theta kind of gives me an indication that,
It's not always my grade.
pi over 6, pi over 6 is gonna allow it to go to 0, because that's gonna be 3 pi over 6.
Yeah.
So 0 to pi over 6, it's gonna be half of what I need. Which means that from negative pi over 6 to 0, it'll probably go here.
So then why, like, if you plugged in pi over 2,
Yeah.
that
That's more, yes, pi over 2 will give you 0, but by then, it would have already moved on to like a different.
okay, so you're looking for the first one.
Yeah.
No, I feel. And I sit here.
Oh, no, I got like a 3 on my first exam, so thanks.
Yeah, I get to be staying a little bit. I can teach you that.
Got it. It's knowing that, I think, has to be a fun. Oh, big window. I got a 4. No, listen. Yeah, I'm surprised by that, because I can't be controlled. And that, and saying with me. That was a funny time. That was a. No, what is it? Talking about.
So I guess that's Friday.
Like,
Yeah.
oh,
May 6th is.
I was like, and she was.